Okay, next one, example 3. A wire with a length of 1 meter is lengthened by 0.6 millimeter when a rod with a mass of 20 kg is hung on it. If the diameter of the wire is 2 millimeter, calculate the stress, the strain, the Young's modulus, and the force constant of the wire. So we are given a wire with the original length of 1 meter. So this is a wire, and then we hang a mass with a mass of 20 kg at the end of it. So apabila kita letakkan a rod, obviously this wire will stretch, so they akan elongate because we are actually putting a force on the wire. So the elongation is 0.6 millimeter. Okay, so we are given the original length here, the elongation, and also the force, which is equal to mg. So this one L naught, this one elongation. So first question, what is the stress of the wire? So keluarkan formula for the stress, which is equal to force divided by area. Okay, so force kita dibagi adalah sama dengan mg, and then area. So area kita akan gunakan dua formula, either in terms of radius, which is pi r square, or in terms of diameter, pi d square divided by 4. So since kita dibagi diameter, here 2 mm, so kita gunakan this formula. Pi d square divided by 4. So you just masukkanlah semua value yang ada. Mass is 20 kg, gravity 9.81 divided by pi. Diameter is 2 mm, convert 2 meter divided by 4. So stress is equal to 6.25 exponent 7 Pascal. Okay, next one, the strain. So we want to find the strain. Keluarkan formula equal to elongation divided by the original length. So this is the elongation, this is the original length. You just masukkan. Make sure they are all in SI unit, which is meter. So elongation adalah 0.6 mm. And then the original length is 1 meter. So sama dengan 0.6 exponent negative 3. There's no unit since this one adalah meter, this one meter, so we can cancel out. And then next one is the Young's modulus. So Young's modulus is equal to the stress divided by the strain. So since kita sudah dapat kedua-dua value, you can just masukkan 6.25 exponent 7 for the stress, and then strain 0.6 exponent negative 3 sama dengan 1.04 exponent 11 Pascal. And then last one, we want to find the force constant of the wire. Force constant, which is the value for K. So value for K kita boleh dapatkan daripada formula Hooke's law, di mana F sama dengan Kx. Force is equal to force constant times with X. X adalah the elongation. So elongation is still the same. Okay, force tadi adalah sama dengan mg. It's 1k times with x, elongation 0.6 exponent negative 3 meter. So k is equal to 3.27 exponent 5. And then the unit, since force unit dia adalah Newton, and then elongation adalah meter, so it will be Newton per meter.